another edition of Up Front with Dennis Vilfort, the storage strategist. Today we have two very exciting guests. We have Barry Ader, who's going to talk to us about a brand new product, and then we have John Segal from the Unified Storage Division, who's going to explain to us how this is changing everything. So welcome to the show, guys.
Hey, thanks for having us, Dennis.
Great to be here.
So, what I've heard, this new product, let's jump straight into it, because I think there's a lot of excitement about this. I think it was a code name called Lightning in the past, and then we changed that around, right? What's it called now, Barry? What's this new product?
Yeah, so we previewed this at EMC World last year under the code name Lightning, and we're about to market a product called EMC UP Cache. And we just went generally available right at the very end of January. So, yeah, it's available right now.
VF Cache. So maybe, Barry, can you explain to us how does this new kid on the block tie into network storage as a whole?
Yeah, absolutely, Dennis. So, let's talk a little bit at first about some of the problems or some of the opportunities that are out there right now. So we know that server technology, chipset technology is growing leaps and bounds. And we know that they're going along Moore's Law, doubling in performance every 18 months, even more so. But unfortunately, disk drives are not getting any faster. So we're seeing a little bit of a gap between what the servers would love to be able to consume and drive back into the application and what disk drives can give out. But there's obviously some great new technology that's out there that can help solve this gap. Flash has been around for many years. EMC since 2008 has been leveraging it within VNX and within VMAX. But now what we're seeing is Flash as an opportunity to be used in a different and exciting way inside the server, closer to the application, in concert with the EMC, VNX, and VMAX storage to deliver incredible performance.
Oh, that's interesting. So you're seeing this sort of as an extension of the array. But does that mean I don't need Flash in the array anymore? Because I know we've been shipping a ton of that stuff, right? And customers are loving our whole fast suite and all that. So I was just moving Flash into the server, and then what? The array just have disk drives? Could you explain that a little bit better?
Sure. No, there's absolutely need for different types of storage and different types of Flash storage in many different places within the I/O stack. And in fact, what you're seeing here with VF Cache is the opportunity to scale out performance inside the server to be able to handle much of your read traffic, but then on the VNX storage to be able to leverage, Flash technology to be able to really handle some of that read traffic, but also a lot of that write traffic.
Interesting. You're bringing up read and write here. So I think I get it, is that if we cache the reads inside the host, we can actually get much better performance. And if we do that on Flash, it's persistent. But why can't I just forget the array then and just go to that model altogether? John, we had a customer who tried to do that. What was it we learned there?
Well, I think first and foremost, what they needed was protection, particularly with the writes, right? So where this comes in, I think, and to take a step back, we've talked about Flash first now for well over a year in the EMC mid-tier particularly. And in the past, we've differentiated hot versus cold data. And now with this, of course, what we've seen with VF Cache now is the capability to further differentiate based on reads versus writes. As Barry alluded to, all the reads now, I should say, the majority of them can now be handled closer to the application, lowering the latency. But at the same time, the writes still need to be handled by a high availability, highly protected shared storage system, and that's where the VNX comes in. And so the customers that we've talked to, I think you're referring to Scripps, which is a recent podcast you had, in fact, tried the server-based Flash approach, but what it was lacking for them was the ability to protect that data as well as improve its performance.
Yeah, Dennis, if I could add to that, basically, customers are dying for more performance and more specifically reduced latency, but at the same time, they can't risk their data. And if you just move data into the server closer to the app and don't protect that data, then what happens when you have a failure? What happens when your server, crashes or something happens to the PCIe card? You still need access to that data. You still need to protect it. And what we're offering here is the ability to get performance, but get performance with protection.
Right, and that's really the best of both worlds that we were talking about earlier.
Yeah, that's a very good point. I hear what you're saying. So you're saying, hey, we cache the data that's most frequently referenced in a lot of reads, so a read-heavy application, content serving, that kind of stuff. We cache that on the server, but then when the server writes new data, then we both cache it, and we also share it with the shared array for protection. Is that the way I'm interpreting that right?
That's right. So all the writes now are protected, right, by the synchronous cache mirroring that we have in the array, and leveraging really all the data integrity and data protection we have in the array as well.
Oh, that's interesting, John. So you're basically saying that data is protected by the shared array, both in DRAM and flash. But does that mean that we're not going to use disk drives anymore anytime soon, or what happens to disk drives in this whole equation?
Well, actually, Dennis, this adds yet another dimension to the data continuum, the flash-first story that we introduced again last year. And so PCIe flash essentially is now serving up, the hottest read-intensive I/O. But yet you still require flash in the array as well as, to your point, disk drives, which would handle the cooler data, if you will. So as data ages, different technologies are going to be leveraged, and so as data becomes cool, it will be handled by the nearline SAS or disk drives, for example.
Yeah, it's all about, obviously, the economics of storage, and leveraging, the right storage at the right place at the right time. And whether it's PCIe in the server, or whether it's flash in the storage array, or whether it's, nearline SAS 7200 spinning drives, for the cooler data. It's about being able to offer the best performance at the best economics.
So you're really saying, Barry, that it's about driving dollar per IOP down and dollars per gigabyte down at the same time?
That's exactly what I'm saying, Dennis, and that's a good way to put it. It's about giving them the best performance, dollar per IOP, at the best cost structure, dollar per gig, and leveraging software across all of those different mediums to be able to manage all that automatically.
Yeah, very well said.
So I thought I get that, guys, but I think a lot of our listeners are asking, well, great, why do I have to go to the host? Why couldn't I just create like a new storage array that had 10 million IOPS and I'll be good to go? Why does it have to go to the host?
Yeah, so let me take that one, Dennis. So PCIe has a great opportunity to be able to deliver much better performance than moving it outside of the server. So delivering less than 50 microseconds for an I/O is something you can't get unless you're on the PCIe bus.
Okay, I think I get it. So this is all about now that I think it only used to be the trading floor applications that dealt in microseconds, but you're saying virtualization is driving this now, and that therefore it makes sense to extend the storage system into the host and basically create a model where the host now works together with the array in some sort of data continuum, and then thereby caching the hottest of the hot data in recache in the host.
That's exactly right.
So, are you seeing great performance enhancements from this strategy? Then, what are some of the early indications that this is a smarter way to fly than the old shared array full of flash?
Yeah, so let me start, John, when we want to add to it. So, we're seeing some great results. It's going to vary a little bit by workload. So, let's start there. Some more read-intensive type of workloads, database kind of workloads are a great fit here for VF Cache. And basically what we're seeing is you start out with a base level array, you add fast cache to it, boy, does your performance go up. You add VF Cache on top of that, and now your performance goes up another 3x. So really being able to, build on top of as a complement to your VNX storage is really what VF Cache can deliver. Oracle workloads, SQL workloads, these are some of the early things that our customers are beginning to deploy with VF Cache and some of the solutions that we're building out.
So I gotta believe that if you allow the reads to be cached in the host and therefore they don't come out of the array anymore, isn't that helping the array also be able to do more for us? Isn't that essentially extending the viability of shared storage?
That's a great point, Dennis. So if you take a typical environment where, read-intensive environment, maybe 80% of the I/O is read-intensive and therefore cached at the host. That's going to free up a majority of the I/O activity and therefore processing power of the array. So you can ultimately get about 4x more I/O that you could leverage for other purposes. So essentially extending the life, if you will, extending the use case, extending the scalability of the array.
Wow, I get it. So I'm supercharging my shared array. I'm getting all the protection I'm used to with a SAN, and I'm still getting super duper high performance because the application is now essentially serving itself in the host where I guess hot data really belongs. So and there's some other benefits, like for instance, what if I am running in a virtualized environment with VMware? Do we support that?
Yeah, so great question. We're actually, this is a product that works in both physical and virtual. So it works in a physical world as well as a VMware world, whether you're at 4.x, whether you're at 5.0, same product across all of those environments.
And what if I'm a Hyper-V customer? Is that supported?
It is not supported yet, but it will be soon.
Okay, cool. So I think I get it. So we're basically coming back to the notion that if you want to talk virtualization and therefore you're utilizing your modern servers much more efficiently than ever before, you're putting tremendous pressure on the array, and you can supercharge that array by essentially extending flash into the host and make those layers work together in a seamless fashion. That's fantastic, guys. So do we have some early success stories from customers, or can you maybe give us a little sneak peek as to what some of the early indications of what the customers are seeing?
Yeah, so some of them include SQL and Oracle environments. I know of one in particular that I'm thinking about right now that's more of a bank application that I unfortunately can't give out the name, but they brought it in, they tested it, they saw immediately, about 2 to 3x performance improvement. And this product is agnostic to the application. The application doesn't even need to change in order for this product to be installed.
So you're basically saying that to get to the next frontier of storage and data management, we're now beginning to blur the lines as to where is the data protected, where is it managed, where is it cached, all that. It's almost like the array and the servers are floating together somehow.
They absolutely are. I mean, I think one of the key strategies that EMC is thinking about and laying out and executing towards is at times it makes sense for the storage to be closer to the app, and there are times when the app makes sense to be closer to the storage. And we're looking at both of those different types of use cases across our portfolio.
Great. Well, it's always changing. It's always exciting to hear what's going on. So, John, any last thoughts here before we wrap it up for today?
I think on one hand, it arrives at a great time, right, where flash adoption is now taking off. It also arrives at a time when virtualization is changing the game in the data center, where you start to hear of stories where eventually servers are going to be handling up to 1 million IOPS, right? And so new architectures are needed in this new cloud world in a data center to address these new virtualized environments. And so I think by leveraging this VF cache, we essentially can now do a scale-out model, if you will, at the server level for hot data, right, to handle that read performance and do so very, very effectively. And at the same time, we can still continue to leverage the protected shared benefits of our VNX storage, for example, which will act as a deep archive for, that cooler data. And then across the board here, we're leveraging fast, right? So fast has now been extended from the storage to the host. So that is really acting as that automation engine, if you will, to ensure, as Barry said, that the right data is always being served up the most cost-effective and highest performing way.
Yeah, fantastic, John. So I think it's almost fair to say, hey, every cloud has a flash lining, huh?
Very good.
Well, we're almost out of time, so I just want to say one more thing. Thank you so much, Barry and John, for joining us here today.
Thanks for having us, Dennis.
Hey, Dennis, thanks for having us on. It's been great.
It's been an absolute pleasure. Thank you so much for dialing in and listening to yet another podcast here at EMC Up Front with storage strategist Dennis Vilfort. Thank you so much for listening.